Hi, this is Hayden Garner,
and Carolyn Mazuka. We're presenting enantiomers, diastereomers,
meso compounds, and constitutional isomers.
So enantiomers are basically just two molecules that are mirror images of one another. And how the mirror image comes about is that the stereocenters are flipped. Now, on a molecule, the stereocenter is basically just a carbon that has four different groups coming off of it. So, for example, on this molecule to the left, there's a stereocenter here and here because there's four different groups coming off of them. So, like, the hydroxide is one, you have this whole thing, which is the second group, this one's a third, and the hydrogen off to the side here is the fourth. So that's a stereocenter. And the same applies for the chlorine. So to draw the enantiomer of this structure, all you have to do is flip both stereocenters. So the first way to do it is, so where this hydroxide group has a dotted wedge, it now becomes a solid wedge. And where the chlorine's a solid wedge, it now becomes a dotted wedge. Very simple. And that's just the stereocenter. The enantiomer, because the stereocenters are both flipped. And the other way to do this structure is to flip the whole molecule rather than the stereocenters. So, whereas both stereocenters are on the left side of the molecule in the original, for the enantiomer, you can draw the stereocenters on the right side of the molecule. And that turns out to be an enantiomer as well. So another concept in stereochemistry is diastereomers. Now, unlike enantiomers, the diastereomers, you only flip one of the stereocenters. So we have the same molecule as before on the left, and to draw the diastereomer of this, you can do it one of two ways. So the first way is you flip one of the groups. So in this case, we're going to keep the hydroxide group the same and flip the chlorine so that it is going backwards rather than forwards. And then you can also do that where you make the hydroxide group come out and leave the chlorine out, in which it would look like this. The hydroxide group with a solid wedge as well as the chlorine. Now if you notice, this molecule and this molecule are both enantiomers of one another, which is just kind of a cool thing of how the stereochemistry works out.
Meso compounds, or mesoisomers, are compounds that have symmetry. Here and here both have symmetry, as well as here and here. Therefore, both compounds are mesoisomers. Constitutional isomers, or structural isomers, for C3H6O. Constitutional isomers have the exact same molecular formula, however, they are attached in different ways. As you will notice, I have 6 examples. First is 2-propanol. You will note that there are 3 carbons, 1, 2, 3, as well as the oxygen and the 6 hydrogens. The cyclopropanol also has the exact same 3 carbons, 1, 2, 3, the oxygen, and the 6 hydrogens. Then the propenyl aldehyde, 1, 2, 3, the oxygen and 6 hydrogens. Again, you'll note that acetone has 1, 2, 3 carbon molecules, 1 oxygen, and 6 hydrogen. Again, the oxetane has 1, 2, 3 carbons, 1 oxygen, and 6 hydrogens. The propylene oxide has 1, 2, 3 carbons, 6 hydrogens, and 1 oxygen. These are all constitutional isomers because they have the same molecular formula, but they have different connectivity points within their specific structures.